Welcome! Today we're going to pull back the curtain on the technology that makes all your favorite apps and websites feel, well, instant. I mean, have you ever really stopped to think about it? How can your favorite app not just completely melt down during a huge fail or a big movie premiere? Millions of people are all hitting it at the same time and it just works. Well, it's not magic, but it's pretty close. It's all thanks to a really clever system humming away behind the scenes. But before we get to the solution, let's talk about the problem. We've all felt that pain, right? That big e-commerce site drops a massive sale, you try to log on and nothing. The whole thing slows to a crawl or just gives up completely. It's so frustrating, and it really just boils down to one thing: way too much demand. So, to fight that digital traffic jam, engineers have a first line of defense, a really simple but powerful trick called caching. The best way to think about it is like this. Imagine a busy store. Instead of running to the back storeroom for every single popular item, you just keep a bunch of them right by the cash register, right? It just saves a ton of time. Caching is the exact same idea for websites. You keep the most popular data in a place that's super quick to grab. Now, the simplest way to do this is with what's called local caching. That's where your quick access spot is right there on a single computer. And look, local caching is fine for a single server, but what happens when your app goes global, when you've got millions of users? Yeah, that's when you need something way more powerful, and that's where distributed caching comes in. All right, so let's jump back to our little e-commerce site. It's using that basic local cache, but now it's exploded in popularity. It's a global sensation. So what do you think happens when millions of people from Tokyo to Toronto all try to shop at the exact same time? Boom, you get a massive bottleneck, a total traffic jam. Everybody's trying to cram through one tiny door to get to that one storeroom. It's a nightmare. Some people might even see old, outdated product info. And for pretty much most people, the site just becomes painfully slow. Now, look at this chart. This shows you exactly what's happening. When you have just a few users, the latency, that's just a fancy word for lag, is super low. Everything feels fast. But look what happens when the user count skyrockets. That single cache just can't keep up. It gets totally overwhelmed and latency shoots through the roof. The whole experience just sucks. Okay, so how do we fix this mess? Let's get to the really elegant solution. The solution that basically powers the entire modern internet. Instead of making one server do all the work, you get a whole team of servers to work together. That's the heart of distributed caching. You're just spreading out the data and the workload across a huge network of computers. Here's what that looks like in the real world. A shopper in Asia wants to look at a product. Boom, the request goes to a nearby cache server right there in Asia. Now someone in North America wants to see the exact same product. Their request goes to a server near them in North America. See what's happening? The data's always stored close to the person asking for it. And the result is a super fast, smooth experience for absolutely everyone, everywhere. But how does a system actually manage all this data? This is where it's really cool. This is the secret sauce. It really comes down to two key superpowers. First up is something called partitioning. Think of this like a citywide library system. You don't put every single book in one giant building, right? No way. You put fiction in one branch, nonfiction in another. That's partitioning. The data gets intelligently split up so no one server gets buried. The second superpower is replication, and this is just what it sounds like, making copies. If one of your library branches has a power outage, it's no big deal because you've got exact copies of all its books ready to go at another branch instantly. So when you put these two things together, you get some amazing benefits. First, the whole system is scalable. Need more capacity? Just add more servers. It's fault tolerant. If one server goes down, the network just reroutes requests and nobody even notices. And finally, and this is the big one for us, you get incredible performance, all because the data is kept physically closer to you. At the end of the day, that's what distributed caching is. It's this invisible hero, this powerful engine humming along in the background. It's the real reason that your favorite apps feel so snappy and reliable, even when it feels like the whole world is using them at once. It really makes you think, doesn't it? We experience the internet as this instant, magical thing, but it's actually built on all these layers of incredible, invisible systems just like this one. So, the next time you tap on an app, maybe you'll wonder what other amazing technologies are out there quietly making it all possible.